Hello, this is Prof. Nanius, and what I want to do is I want to make a quick video about lines. And the question is, if you have two lines that are perpendicular and you're not talking about one line having slope 0 and the other one having undefined slope, prove that the slopes are negative reciprocals of each other. That is, if the first line has slope m, the line perpendicular to it will have slope negative 1 over m, provided m is not 0. Now, if you know what vectors are, if you know what the dot product is, if you know that, if you know the following formula, we'll share screen here. If you know, and I'll just make this clear, I'll get down here. Now better if I'm using a little webcam here. Do the pencil, make it readable. Let's see. If you know following formula, cosine theta, angle between the two vectors. You know what a dot product is. Then you were over, then quit watching. You were overqualified for this video. We're not going to use vector calculus for this, or we're not going to use the inner product. And if you know that there's different kinds of ways of measuring angles, please, this is not for you. So this is the idea. So we're going to go ahead and start. And we'll assume that we have lines L1 and L2, which intersect in a right angle. Now, they can intersect anywhere in the plane, like so, right? So what you can actually do is you can take this pair of lines and you can rigidly move them to the origin. Or alternately, what you could do is you can draw a circle. And I'm going to use the radius 1 for convenience right here. So you can think about it also as drawing a circle, radius 1, with that as the center, like I'm doing here. So pretend we've already done that. And for those of you who don't know, this is sometimes called a coordinate shift or a change of coordinates. It's a big idea in physics and engineering. And so let's go ahead and do that. We have our lines M1, M2, and we assume that this is a right angle here. So, like so. So this line has slope M1. Well, this means that if I look at the rise over the run, that ratio is M1. Well, if you measure this as an angle, say theta, then what this says is that and again, you're assuming that this has radius 1. What this is basically saying is the opposite, sine theta over cosine theta, which is tangent theta. That's going to be the slope M1. That's rise over run. Now, because this is a right angle, the following angle, if I measure from here all the way to here, that's going to be theta. And then we add a pi over 2 because that's the right angle you're adding to it. So we know the second slope, it is going to be rise over run as well, but basically this is going to be tangent. Whoops, I didn't mean that. Of theta plus pi over 2. Now let's rewrite this as sine of theta 1 plus pi over 2 over cosine of theta 1 plus pi over 2. Now I am going to pull a little bit of trig out here. And I'm going to go ahead and just erase this because this doesn't really add much to anything. Probably was a dork to even just put it there. But let's go ahead and finish this up. Now we see this right here. Now let's just use some trig identity. I better go back to this. Let's do some trig identity. Well, sine of theta 1 plus this, by using the angle addition formula, this is sine of theta 1 cosine pi over 2, which is 0, plus cosine of theta 1 sine of pi over 2. Or you can write this as cosine of theta 1. The bottom right here, adding pi over 2. Well, using the angle addition formula, that's cosine of theta 1 cosine of pi over 2, oops, minus sine of theta 1, or yeah, theta 1, right? Yeah, I'll just call this theta 1 here. Don't know where the 1 came from. And then sine of pi over 2 is a 1, right? But that's just M2. So I'll just go ahead and write that theta 1 here, just to cover for my mistake. Now, if you multiply M1 times M2, we get cosine theta 1 minus sine theta 1 times, well, that's the M2 part. Here's the M1, sine theta 1 cosine theta 1. And notice, lo and behold, you get -1. So M1 times M2 is in fact -1. So there are negative reciprocals. Okay. So that is how you do it. I won't deny that doing it vector calculus y with a dot product is a lot better. But if you don't know vectors, well, this is what you got to do, or something like this. Thanks for watching.